Hello, this is the introduction for a series of videos where I want to show how to create a full stack app entirely written in Golang. So we will create this, just a Postgres database, then one backend component that reads from it and exposes the information following the logic with fine on it. And then we'll have finally this frontend component, which can be thought as the main application. And you could think about the framework as this, as having one main component and then a lot of satellite components that serve some function and are dedicated just to this front-end app. And all is written with Go, so the front-end will use HTML template, the library of Golang to render the templates that we will define with HTML and the styling with CSS. And at the end, we'll have just a browser app that is used as a calendar. So this is quickly how we are going to do this. First the database, then the backend, and finally the frontend. Okay, and we can just see quickly how this will end up looking. This is the monthly view. We can switch to the yearly view. We can access the months here and see how many tasks for month we have. The month, again, the weekly view, and the daily week, which we can access as well from the week or the month just by clicking the day. And here we see that we have one task, and we can create another one. For example, second task. And we can create this even earlier, although this is unrealistic. We can change the color to yellow, and if we create this, we see that this appears here now. We can set this as complete or mark it again as free as to do, and also we can delete this. So if we click here, now we see that we only have one task. So this is all. Just one quick remark is that we don't need a REST API because we have both components speaking the same language. So we can just tag the version and use the interfaces directly, instantiate the interfaces and use the methods defined on it. So as you will see, this is a straightforward approach. There's a lot of code, but at the end, the concept is as clear as this. So I hope this is clear and we can proceed to start programming this. So here I create this folder. The backend app is going to be here, and I'm going to just init it. I'm going to put my complete path framework, go full stack backend, for example, and here we will have this. So I want to create the structure first. I want to have a package where I'm going to define all the types that are and the interfaces to be read outside of the application. And of course, the internal ones are going to be in the internal. I also want, of course, git ignore. I also want a Docker compose YAML. I also want some things I'm going to, it's going to be added later, but now currently we are going to focus on this one. So first of all, we want to create database before writing any code in Golang. So let's go and let's put it in here. And I'm just going to copy it to make it faster. But this is the init. And here I want to copy my types. So we are going to create a task table with an ID, which is just an internal identification. This would be used if we are going to make links, for example, with the external key. This would be the primary key. In this case, this wouldn't be necessary, but we could add, for example, I don't know, like some authentication, and we could relate all the tasks for an author or something like this. The one that is going to be used, for example, to remove or edit tasks is a display ID in the front end where we send the request to the backend. We are going to specify this ID. Then just the regular features, the name, the description, just two timestamps, start and finish, the priority, the color, and complete. And indeed, these two, they are the same concept. It's just some number which can be related to something like low priority, priority ID equal to 0, blah, blah. The color is the same, so we can keep it short and just show one of these features instead of the two. And finally, the completed, which is a Boolean. So let's see how we connect these to the to the Golang types, we can go in the package, and inside here, this is going to be created in model. And inside model, we need the definition of the types. This is the package model. And here inside, in the types, we can create the task. And the task, I like to compose the types because these two are set automatically when we create a task. So I like to add an updatable task, which is the type that it's going to be required in the methods. Okay, and here we see that we introduce the first library, time for the start and finish, and then we need to. This is going to be out. We are going to put the color ID as this type that we need to create. So first of all, we can create this just below, and we want to make a validation. Okay, so here we introduced two things that needs to be created as well. First of all is the color that is used as the limit. So more than this, we want to show that we don't know the color ID. So this prevents us to use an ID that is not previously defined, and the definitions are going to be stored in constants. And these constants, you can add whatever you like, but I came up with all these 9 colors, IDs, sorry, and this is the one that marks the end of all the IDs. If we would like to create another one, we would just add this here. We'll keep this separate to differentiate them. So now this error went out, and finally we need to add the error, and this is going to be created as well in the model. And here there's different approaches to errors, but I like the cleanest one, which is just to define it as the interface that implements the error function. So it's all what the error needs. And okay, we want this error. This is a model type error, and we call this error unknown color ID, which will be equal to unknown color string. Sorry, const error. So this is our first error, and here we'll be adding all the errors that we encounter. So coming back here, everything is set up. We can start just with this. I think this is enough. Now what we should do is to add the interfaces, of course, and this is the contract for our data types and our managing instance that is going to be called in the front end. So let's go for it. We call these interfaces. And here we define type task DAO. This is a pattern from Java, I think. The data access object. And we can just copy paste a series of methods with some definitions. So you see here that we are going to create tasks. The parameter is the updatable task that we created before. So we just need to introduce the name, the description, the starts and finishes, and the color. And automatically the completed will be set up to false by default. To switch it to true, we need to click another button. We need to trigger another method, which is defined below, and the task ID, which is auto-generated in the database. Then we can edit the task, although I'm not going to use this in the front end now, so I'll keep it short because we have the set complete as an edit action where we only edit one field. The other one would be editing different fields, and I prefer to keep it a bit simpler. So the second usual method is the remove. We just introduce the auto-generated ID. Then the mentioned set completed, which we can set as complete or as incomplete, so we can switch it back to the initial state of this being false. We just specify this here. And finally, we need this list task to get the information. And here we will make this a bit generic. So we'll create a time filter, and then we'll find the time branch that we want to include in the query. And it will output all the tasks that are fit inside this time branch. So we need to define the time filter. We could define this in type, but I prefer to define this in the model, in the other folder, filters, I guess. And in filters, we need to define a time scale. Where's the package? We need to define a time scale ID with uppercase because we are going to use this in the generators, which are going to live outside of the package model. And then we always want a validate timescale ID validate. This is going to be used in the mapping, in the internal, when we are mapping the types given by the Postgres driver to convert it to our types. We need to validate the same types. So this is a common practice. We need to have everything covered for possible errors. Last time scale ID, the same pattern as before. We're going to say that everything is okay, and if not, we are going to throw the unknown time scale type ID. Timescale type ID, okay. Timescale, not type, timescale ID, just following the name of the type. And thus we need to create this error here in errors, as is model type, const error, and unknown time scale ID. Okay, timescale. We can close things, and then here, okay, the time filter is still not defined, but we are going step by step. First, the timescale ID, which is a field inside of the filter, and we need to create our types. And this is going to be shorter than before. We need the daily. We want a daily. We want a weekly. We want a monthly, and we want a yearly timescale. So let's initialize this as before. And here we don't need to, this is going to be added automatically in the generator, so it's going to be internally set, so we don't need to export it. That's the not capitalizing this. And here, what do we need? We need to implement all the interfaces for the time filter. So sorry, this is going to interfaces. We define the interface time filter, which forces you, if you want to use a time filter, you can define them, but they need to include these methods: the validate, the get timescale, this internally for validation purposes, and the time branch is to be used in the methods later. So we defined the timescales. We have the daily, weekly, monthly, yearly. So now we need to implement these interfaces. So these will be types that will be used to list the task. Okay, so we can proceed with all the filters. We can start with the yearly. Okay, first of all, we create the type. We allocate one field in the year. We'll see that we will nest the fields. We will instantiate this. We will force the instantiation with a method. We don't want the frontend or the serving apps to be creating this freely, but this is just convenience or something that I like to do. Then we need to implement the methods, just validate this, get the timescale ID in the validation. So we need to create the field, the method, sorry, is the get timescale, and then some validation. We need the lower bound, which is going to be added in as a constant. So here we got constants, we add lower year bound. I don't want to create tasks, but I think I closed it. We don't want to create tasks very far away in the time, just 2 years ago at most. And then we would throw this error otherwise. So let's go back to errors and let's add the invalid year error here below. And this is implemented. We have the validate, we have the get timescale ID, and then now we need the get range. We need to get the range to make this work. And in this case, we will get the another method which is not necessary for the interface, but by default we'll add the UTC location, but then in the visualization we will take the location of the browser, the computer, and we will show the times correspondingly to the location. Okay, so here we added the date. For the year, we just take the year defined in the type. So when we initialize the filter, we set the year, and then this year is the range is the whole year. So we just need to add 1 year to the date and return both times. And we need to proceed and do the same for the monthly filter. So let's create monthly filter. Here we need the year, and we will compose it. We will use the year filter because we have the validations and the methods associated with it. We will add the month, which is a new field, and then we will force the initialization method here. We just create the type. Again, this is the same, so we can skip, copy everything, validate. We get the timescale. We validate the timescale here. We validate the year. We don't add a new validation for the month. And the timescale ID returns the timescale ID month. We need to match the timescales. We want the time range here. It's the same, but here we just add 1 month. So we get the range of the month is from beginning to the end of to the beginning of the next month, which 1 second less is the previous month. So it's the top, the upper bound for the month. And again, we can copy this again for the filter. Same pattern. We add the year, and here we need the week, which will be the ISO week, and we will get the new weekly filter again, the constructor. We compose the year again, as I said, and here the validation. We won't allow the invalid week here instead of the other one, so we will add the other here, const valid week. Okay, close it, please, close, validate, get timescale, and now we will create the time range method, final method to implement the interface. So here this is a bit more verbose, but at the end, because we need to do some dirty loop. We need to start in the middle of the year, then roll back to the Monday of the week, then keep adding days until we get what we want. And so we get the beginning of the week, and then we add 6 days to go to the Sunday to get the final day of the week. And this is all for the weekly. And then finally we need the daily, which is composed. It uses the monthly filter, which uses at the same time the year. So we have, for the daily filter, we have the information of the day, the month, and the year, which is all we need to know where we are in time. And the same, new daily filter, validate, get timescale ID day, and the same as year and month to get just 1 day ahead as the upper bound for this branch. Okay, and this is all the types, the filters, and the interfaces. I want to see if I forgot something, but I think now we have everything we need. So and we'll see if we forgot something, but this is the structure. We have types, we have the interfaces, and now we will need to implement them and make them be available for the other apps to use it. So definitions in model, database here. Let's go to the next step. We want to initialize the database. We want to connect it to our interfaces. So we want to implement all these methods defined here. And in order to do this, we need to start defining things inside of internal. And the first one is the configuration and the initialization of the database. This will be done like this. We create the main package here. It will be called DAO, so we know that this is related to the interface defined. And this is the most important file because we are going to define the configuration and define how we can make the connection to our database. So we need to define this config struct. We'll have the typical things, the connection string, and some parameters here. Next, we'll be using the library pgexpool. So we need to define we need to import this in our Go mode directly. So let's check the version I want. We want to make sure that we have the last version, and at least I want this one. I'm using this one currently. So this is the one, the 5th version. So now we can just run go mode tidy to get the library. First we need to be using it here, because if not, VS Code is kind of taking it out. So let's do this first. Let's import it. So now we know that the one that we are using it to take here, the pool inside of it, it's living inside this library. And now finally we can just add this again, just run the go mode tidy. And here we have it, we have this library, so we can create the interface, so the structure that we will implement the interface that was defined before again. And here we'll use this to check that we are implementing all the methods. We want the model to be our model. We call this Go fullstack backend, so we want to make sure that we are using this, and we are taking this from the package model. Okay, so here we see task is not defined. It is defined. I don't know what is fullstack backend. We define this here. Task okay. This is without yes. So here we can see that we cannot use this as the task defined value because we have still not implemented, and besides we need to implement it with correct types and correct definitions. So this is still not properly defined. We'll keep it here so we know when are we doing things right or not, just for validation purposes. And then we are going to define the new PSQL DAO function to initialize the configuration and the interface. So in the body of it, we are going to do a quick check to check if the config is nil. Then we are going to throw this error. So we are going to define this new error inside of the model errors that we started defining before. And here we have this first error is the one that we added now, so we can use it directly here. Then we are going to initialize the pool with a function that we are going to define next. But first of all, let's create the body of this one. We are going to switch the write enabled parameters, so we know that we want to be able to write in the database or not. So we'll be able to create an empty pool. This is just some configurations and parameters, so we can use the database in different ways. We are just going to use the write by default, but I like to define both of them. So we can just define a read-only one, for example, for some applications we want to restrict the access to information in others, and so on. So it's useful to have this definition here. So now we see that we introduced as well the fake write pool error, which is defined as well below the freshly new introduced nil not allowed error. We introduced the fake write pool, and I think this is all we introduced here. So once we initialize the pool, we just return the interface, which is going to implement the methods, and this is going to be done next. But first of all, let's just add the initialize pool function. As you see here, we just pass the configuration, introduce the max pool size, get the context with a timeout, so we can check if the connection is not working properly after 11 seconds. If it doesn't respond, we just cancel it, and we create the pool with the defined pool config, and then we ping it, so we check that everything is fine with the context, and we return the pool. And this return is going to be used in the previous function here when we have a fully functional database with write privileges. And then the other one, which is similar, but we don't need to introduce any connection string here. So this is easier. We get the connection configuration from PGX, and here this is not correct. We need to introduce the 5th version. This library path configuration for PGX was changed from the 4th to the 5th version, so make sure that you introduce the 5th one for the purposes of this video and this application. And here we see that we find everything we want. This is going to be used, this is the internal initialization of the pool, and this is going to be exported later in the package. We are going to find another package here, and we are going to just call these methods so we expose what we want outside of this application. Okay, so this is all for this DAO package, and now I would like first to create some tests and then some integration, not integration test, integration will come later, but now the unit test for checking that we can use this function, just a quick check, a quick test, and then we are going to introduce and implement all the methods finding the interfaces, so we will be able later to again to create the integration tests for them. This is the most important. They are the most important tests here, so we are going to spend some time with integration tests, but this comes after the creation of the methods. So we want now to create to make the quick test, and then we will focus on getting rid of this error. So let's define the unit test first. We are going to add this directly here as DAO test, and here we want to make one thing, which is to add a go build tag. So we make sure that we are not building this unless we specify it, and this is going to be done like this, so specifying the unit test tag. And here we are going to define DAO. Now you see that the Visual Studio Code, it doesn't detect the path here because it's not running. It's not doing the static check with the tag. It's going to be added in a second, but first of all I want just to add the quick test here. So we want first of all again to introduce the new library for this, which is this one I'm going to attach right now. I have to check the version first. I want stretch testify with this exact version. I want to event this. I don't know why VS Code is not auto-eventing the mod files. I should have probably some extension for this and make it later. So we added this one, and now let's run the command again, and we face the same errors. First of all, let's do as before. Let's just add the test. So we want to make this empty pool test. Here we are going to import testing and assert, so the built-in library testing, and external library assert. And to make assert work, we just start at the first one, assert new, okay, and then we can come back here and we can make it official. So now we have the testify, and so we can use the assert for our tests. Let's quickly add the test, which is just the initialized empty pool function. We will check this. The initialized pool, the normal one, will be tested in the integration one, so no worries about this. It's going to be added in a second. So now, first of all, I want to get rid of this warning. I want VS Code to be able to read and check the errors here. And in order to do this, we need to go to the settings, like this, and we want to check extensions, go to the tags section, which is here, and we are going to add unit test. And later we'll do another exercise. We'll come back here and we'll add the integration test, but we'll check this again later, so we can see how it works again. And you see that here we don't get the error again. And now we could just run the test, I assume. We get this error. Okay, we'll comment this briefly so we can check the first unit test here. And we see that the function works properly. We don't have any Postgres database running right now, so we don't need this for the empty pool, which is just doing this, creating a nonsense non-existing database connection string, then initializing with this configuration and just checking that it doesn't work. So this is it. We have our first unit test. So now we'll be able to start creating and implementing the methods, which is the most important part for this backend application. So let's just quickly close some things so we make it clear. We are going to let the interfaces file open, so we see what do we need to implement and check it. The DAO one, we are going to leave it open again. I want to uncomment this now, and we are going to make this error vanish. So this one, let's close it, but we are going to open it again because we are going to use other libraries for the mapping and so on. So we are ready to go.